Look at addition and subtraction, and we'll start with addition. And when I say basic, what I mean really is single digit addition. In tables, we would refer to them as the single digit multiplication. We'll do that next week, but this week we're going to focus particularly just on addition and subtraction facts. So let me describe them to you, and I'll just show you a little chart that will sort of focus you a little bit on what we mean by those basic addition facts. So I'm just going to show you an addition table, and you'll see it just down here at the moment. And you'll notice that what we've got here is single digit numbers along the top and down the side. And in this table here, we're looking at things like what's 4 and 3, or what is 6 and 3, or what would 8 and 5 be. So it's really about single digit numbers that we're talking about. So our focus today is going to be on just those single digit numbers, because when you do other calculations, you're basically reusing those single digit numbers. So there's about 5 strategies that we'll focus on, but before you can even do any of them, there are 3 basic prerequisites. So we'll talk about strategy number 1, and I'm just going to change over to a different example here, and you can see it. I'll just bring it up for you. And we've color coded it just to make it a bit simpler to follow there. But essentially, the first strategy that we have is you need to be able to count on, what they call the count on facts. Now, in terms of counting on, what we're talking about is counting on from the larger number. So an example would be a very young child, if they were adding, say, 4 and 2, might go 1, 2, 3, 4, 5, 6. In other words, they call that count all. Now, count all is a reasonable strategy to start with, but it's quite laborious, and therefore, the more steps you have, the more chance you have of making a mistake. So what we'd rather than do is start from the larger number. So if you were counting, adding what 4 and 2 is, you start from the larger number, which is 4, hold the 4 in your head, and then count 5, 6. So you're doing less labor, therefore less likely to be error prone. However, that implies 3 things. So I'll just focus you back on the chart for a moment. If we're going to count on from the larger number, there's 3 things that we need to know. First, we need to be able to identify what the larger number is. For example, if I asked you to add 2 and 4, you'd have to turn it around and start with the 4. So that's a whole nother strategy. And I'll talk about that idea of this turning around idea. So I was adding 2 and 4, but now I've got to turn it around. Now, the fancy name is the commutative property of addition. We would call that the turnaround facts. So I have to turn that around. So we'll talk about a way of doing that. The second is I have to hold the 4 in my head, and then I have to count 5, 6. So there's 3 places I might have trouble. One is I don't know about turning around. 2 is I can't identify what the larger number is. And 3, I start the count at the wrong place. In other words, when I go 4, I might count 4, 5 instead of counting 5, 6. So holding the 4 in my head and so forth. So let's look at a couple of things that might do that. And I'll just show you a couple of examples down here. An example might be if we take here, let's just take a standard domino. We can see there's our domino. It happens to be a 6-2 domino. If we counted the dots, there'd be 8 dots. But it doesn't matter whether I have it turned around that way or I have it turned around this way, there's still 8 dots. So this is this notion of being able to turn around, or this commutative property of addition. We could do the same thing with bead strings. People have probably seen bead strings before. I'll just take 10 of those beads for now, and then I'm going to split it. In this case here, you can see it's split into 7 and 3. But if I turn that bead string around, it's split into 3 and 7, but there are still 10 beads altogether. So that's that property. So what we're talking about is that turning around is that commutative property of addition. If we get that idea, then it nearly halves the number of basic addition facts that we need to learn. So let's look at the first set that we need to learn. And I'm going to show you just a couple of things with that. And I'm going to use some cubes, but you could easily use Lego bricks, any of that sort of thing that join together to show the same idea. So I'll just put them down on the sheet and we'll just have a bit of a look at it. Okay, in this case here, what I've got is, you'll see here, I can pull them apart. and I've got 5 of one colour, and I'd like to keep them all the same colour. So essentially we've got 5 and 2. And what we're doing is counting on from the larger number, in this case by 2. So there's my 5, then I've got my 6 and 7. When I work with children, see, addition is about the action of joining and or combining. And so now I say, hold the 5. You see how I'm holding that 5? And now I count on 6, 7. So it avoids them going 5, 6, trying to get that sort of notion that's happening here. By the way, I can still turn that around, and 2 and 5, if you have a look here, we'll just show you here, I've just turned it around, 2 and 5 gives me the same result as 5 and 2. So let's just talk a little bit about those count on facts. And you notice we've color coded this sheet, and you can always download things called Milestones from my website. They'll talk about the order in which these are taught, and they'll have these sort of pictures, but in small size. So the count on from the larger facts, we could count on 1, we could count on 2, we could count on 3, we could also count on 0, which some children find very difficult, in that adding nothing makes no change to it. And so what we've done is, you have a look down here, we'll show you what I mean. What we've got here is they're color coded. So these mauve ones here, they're all the count on 1 facts. The yellow ones are all the count on 2 facts, and the light blue ones are all the count on 3 facts. Now, with one strategy called count on from the larger number, so this one strategy, count on from the larger number by 1, 2, 3, or 0, you actually are learning 64, or 2/3 of all your basic addition facts. So we're getting this notion of learning the facts. Later on, we need to be faster at them and recall them. But when we're learning them, count on from the larger 1, 2, 3, or 0 is the first strategy. Now, some people refer to that as think big, count small. So you're doing less work to get to that idea. Now, let me give you an example of a dice game that might develop that sort of thing. So I'm just going to move this off, and then we'll put 2 dice on the thing there. We have a look at the dice. Okay, so I've used 2 distinctly different coloured dice just to illustrate that to it. So we might be playing a dice game. These are dot dice, and we've got here's a classic example of a strategy, think big and count small. So what we're trying to avoid is the children counting the individual dots on the dice. And now and again, I'll substitute a numeral dice just to shake it up a little bit, so to speak. But let's focus on what we're going to talk about with these 2 dice. So we're playing a game, maybe it's got 2 dice in it, but here's what we're going to say. So now if we just look at the dice again, you'll notice what I'm going to focus on here. The child who wants to start here, I'd say, hang on, think big, count small. So what's the bigger number? It's 6. So what do I got to do? I've got to hold the 6 in my head, and then I'm going to count on 7, 8. So they're not being counting in ones, counting all the time. And the other thing that children need to be able to do is a thing called trust the count. They need to be happy that the count's going to stay the same. I don't have to recount all the time. Now I'll show you the same thing with the beads, same sort of idea. So just put a set of beads here, a bead string. This happens to have 20 beads on it. You can use one with 10 beads, doesn't matter. And you'll notice that in this case here, the beads are alternating every 5, because kids can do a thing called sabotage, or hold in their head this 5-ness without having to count. Now let's just have a look here. I'm going to slide across, and you'll see what I'm doing is sliding from the right to the left, so it gets larger as you move across. So you see there's 5 beads here, and then basically I'm now going to count 6, 7. So you can see there I was holding the 5 and then counting on another 2. So that's just use of the beads as an example. Now, we spent a bit of time on that strategy, but as I said, that will cover 2/3 of all your basic addition facts, one strategy. Now, you need to build up some facts in order to sort of get a feel for this sort of idea. Now, I want to put in one other little chart here, just to give you an idea. And if you have a look here, it's what they call a part-part whole diagram that's sitting here. Because while we're learning addition facts, and you'll see there, we're going to talk about one part, another part, and the whole. So there's 3 elements, this idea of addition, that are coming to the fore here. So let me focus you back on the diagram, and then we'll just have a bit of a look at that sort of thing. Okay, so this diagram here, you'll see one part was 5, another part's 4, and the total, the sum altogether, that sort of language that's sitting here gives me 9. So that's your stock standard question, and all I'm going to do is cover one of these, okay? So here's your typical addition question, 5 and 4, what's the sum altogether, how much do I have, and so forth. And we use materials to do that to start with, but later we use numbers. But what we want to try and do is also, relate the addition facts to the subtraction facts while we're learning them. And so I'll get you to have another look at this diagram and see how I cover a different part of the diagram. So in this case here, we covered the answer, so to speak. But now if we did it this way, we have what we call a missing part question. And this is asking, well, 5 and what is 9? Or 9 take 5 gives me what? You start to see how those things are linked together. And so while we're building this idea of addition, we're linking it to the subtraction. So if you think about it, if you know that 5 and 4 is 9, you should also know that 4 and 5 is 9. You should know 9 take 5 is 4. 9 take 4 is 5. 5 and what is 9? 4 and what is 9? Can you start to see how they all link together? And in fact, you're developing this basic idea of some algebra sitting here. There's one more link I'd like to show you. So let's just have a look at the part-whole diagram again, and I'll describe what I mean. In this case here, this one's actually one of the harder ones for children to understand. Let me use an expression. Let's talk about some lollies. So the original question was, I had 5 lollies, my friend gave me 4 lollies, and altogether I've now got 9 lollies. The second question was, I had 5 lollies, my friend gave me some lollies, I don't know how many, and altogether I've got 9 lollies. How many did my friend give me? But the third question is quite difficult. I've got no idea how many lollies I had to start with, and then my friend gave me 4 lollies, and now I've got 9. How many do I have to start with? So essentially what we're talking about here is we spend a fair bit of time putting what I call the bolts in the wet cement. What I mean by that is laying a really good foundation for kids to bolt onto. So if you have a tilt-up concrete building, if you put the bolts in the wet cement well, everything else joins in extremely well. And that's why I like to have spend a lot of time with the early childhood really developing these ideas, and they will carry you right through the school. But let's look at another strategy. In fact, we've looked at it before, but I just want to have a focus on another one. Here's all the facts that add to 10. So we'll just put this one on the thing here. So once we've learned the facts, the count on 1, 2, or 3 facts, the next set of facts that we would talk about is those that add to 10. Now, really, you've already learnt some, because you've already learned count on from 9, 1 more is 10. Count on from 8, 2 more is 10. Count on from 7, 3 more is 10. And then you've got those turnaround facts, so 3 and 7, 2 and 8, 1 and 9. And of course, you've got 10 and 0 later on. But there's 3 brand new facts that you're going to learn. What 6 and 4 is, and 4 and 6, and then 5 and 5, which is actually a double as well. Now, we actually played a game in a previous webinar, but I'll just remind you about it. It was this one here, and I'll just put it down here for you to see. We played a game called Build To. Now, the game we played before was Build to 10. And you might remember I put a spinner on there and we flicked the spinner. Okay, in this case, the spinner landed on 6, and you'll spot it at this point here. And then, so I would put my counter on 4, because that's the number that builds 6 and 4 builds to 10. And so basically I have a series of little games just setting up on the web. They go by obvious names. Like there is a game called Count On, which related to the first strategy. This game's called Build To. We could play Build to 10 or Build to 20, any sort of decade. But I'd like to just share a tool that will help us with this idea as well. And the tool's going to be called a tens frame. So I'll just put that on the video monitor here. And you see there's a tens frame. And essentially, look, if you don't have one of these at home, you could do it with an egg carton and cut 2 sections off would be fine. But essentially what we're doing is we're filling this up. And normally I like to use the same color. And I'm going to fill this top deck of the double-decker bus to start with. And so in this case, I'm filling up 7. And so can you see the whole is 10? Remember that we talked about this part whole idea before? And we said, okay, what's the whole? Well, if it's a 10 frame, the whole is 10. And so now what we're going to look at the 2 parts, and that's what the 2-sided counters allow me to do, to focus on the 2 parts. So if we just go back and have a look, you'll see that I now have a part here, and you'll see there's the part. It's 7. Okay, what's the missing part, which we had before? Well, for some children, they'll need to physically put the counters on to see that. Now, if you're using an egg carton, you could put anything in the eggs. Remember to cut the end off. So now I can see that 7 and 3 is 10. I can turn it around if you wanted to. 3 and 7 is 10, same sort of idea. We can look at the parts and so forth. Now that means we can make a pretty simple game here. If I just tip those off for now. So I've got my 10 frame, and if I just rolled a 10-sided dice, in this case here, so I might get something like 8 that shows up in there. I put 8 counters on. How many more would it need to make to 10 and so forth? So that's the strategy, which is really about the things that go to 10 or the facts that are about 10. Pretty important, because when you count or you work out to any decade, you're using that general idea. So just a reminder, we've done strategy 1, which was count on from the larger number by 1, 2, 3, or 0. Now you might wonder why I'm restricting that. Well, children can only hold so many things in their head. So if I'm trying to hold this, count on from the right spot, if I count on too far, often I can lose track. The second strategy, which actually revises some of the first strategy, is the notion of this, what we're going to talk about, this things that add to 10, but we've already learnt some. We've learnt the 9 and 1, the 8 and 2, and the 7 and 3, and so on. So we're going to look at another strategy now. The one that we're going to look at is the doubles facts, and I'll just put them up as an example. Okay, so in this case here, we have the double facts, and I've just highlighted them in yellow. You can start to see them running down the diagonal across here. They're all the things like what is 1 and 1, and 2 and 2, and 4 and 4, etc. All of those sort of things. Now, often things come in packages of pairs, like soap packets or pairs of shoes. So we're often used to doing things of doubles. When you could get toilet paper, they would also come in often pairs or 2 lots of 4 or something like that, and so forth. Now, same sort of thing. We've played one game already today, the Build 2 game. Essentially, once you've played that game, then you've played a bunch of others that are just sitting on my website. But I'll give you an example. Here's a game. It's pretty obvious what it is. It's about doubles. So let's have a look at this notion here. Now we can create a spinner. Remember we did one before and we had a paper clip. And we put that in here and we spun the paper clip around. So I'll put a paper clip on here so you can see. And we just put the paper clip sitting in here. We put a pen point in here and we did a spin around the paper clip. That was that example there. You could just put a plastic template on there and spin. But the way this game works is you simply spin. Now let me put it, say here, let's imagine I had spun 5, then I have to double that number. And I like to use the see-through counters, the transparent counters here. And when I play, I like to have people of different colors. So someone might be blue. And so if I've got double 5, I could put it on that 10, but I don't have to put it on that 10. I could put it on that 10. I could put it on this one. But the aim of the game is for me to get 3 or 4 of my counters in a row, column, or diagonal. So imagine another player went, and I'm just going to rig this a little bit. So imagine I got onto 6, and double 6 is 12. So I put that in there, and I'm trying to block the other person from getting their number. So they got 3 in a row, column, or diagonal. So once again, once you know how to play one game, you can sort of take that same idea and just repeat it and repeat it and repeat it. And using the same paper clip, the same general idea of covering some numbers and so forth. So let me remind you now. So we've done 3 strategies. We've done count on from the larger 1, 2, or 3, or 0. We've done the facts that add to 10. And now we've looked at doubles. Now, a couple of other ways that we could do doubles. Let's go back to the same equipment that we've been using before. We could go back to our tens frame. In our tens frame, we could look at what double 4 is. So I'm going to put 4 counters here. So that's 4. But if we're going to double it, you'll start to see here where I've just done this sort of idea. So you can see that double 4, you can see that it's 8. And it's clearly what the doubles are. Now, as you get to larger doubles, you might have to put 2 10 frames together to do the same thing. We could use, for example, the bead strings that we had before. And what we'd have in this case is we'd need 2 bead strings. So let me illustrate what I mean. So I just put 2 bead strings down here. In this case here, because we're already familiar with the bead strings, we can put, there's one of them, there's another, I'll just move the other beads off there. And we can see now, I'm going to turn that around a little bit so you'll get the same sort of thing. So we can see here that there's 10 and there's 10, double 10 is 20. But we could have done 6 and another 6. So there's our doubles there that would sit in here. So you can start to see where the doubles sit. That's double 6. So it's just a different tool. I like to have just a few tools, but use them regularly so you start to see the same sort of idea. We can play with a couple of other tools later on just to give you that notion. Now, of course, if we've got a strategy called doubles, there is another strategy, and that's called your near doubles. And so I'll just put those ones up so you can see what the near doubles are. Put that in there. In this case, I've just highlighted them with the blue. Now, just bear in mind, the doubles facts that we were just looking at, they're these ones that run right through the center. And you'll see that the near doubles are close by. That's why they're called near doubles here. So an example of a near doubles calculation would be saying something like, well, I'm trying to work out what 6 and 7 is, but I don't know exactly what 6 and 7 is, but I do know what 6 and 6 is. So 6 and 6 is 12, and one more would give me the 13. Or another way of thinking about adding 6 and 7 would be to say, well, it's like 7 and 7, but taking one away. So you do a nearby calculation, in this case a double, and then you make an adjustment so that you can get to the answer. However, this implies something fairly important. If you don't know your doubles, how could you possibly do a near double strategy? So you need to have some level of recall. Doesn't have to be instantaneous, but some level of recall of these facts that are called doubles. And then the idea would be that you then make an adjustment to work out what the near double is. So once again, you could take the same idea. On my website, I've got a game called Doubles and One More, Doubles Take One. It's just building that sort of practice that sits here. Now, if we have a look here, we can see what happens. Basically, if we have a double, we'll use the same things we did before. We'll use the bead strings, and I'll show you what it looks like as a near double strategy. So in our previous example, we had 6 and 6, which you could work out was 12. But we can see here, just by moving that one bead across, that we've now got 6 and 6 and one more. So if I knew the double, what 6 and 6 is, I just need to add one more. Or likewise, I could say it's one less than 7 and 7. So that's this idea of a near double strategy that we're looking at. Now, there's one more strategy that we need to have in place to finish off all of our basic facts, and it's called bridging 10. So I just put that up there so you can see a little graphic of that, and we're referring to all of these purple bits here. Now, bridging 10 involves 3 separate ideas that are happening here. So remember, you already learned 4 strategies. You've learned most of your basic facts. This is just filling out the last few that's sitting in here. In order to do a bridging 10 strategy, there are 3 separate ideas that we need to put in place. Now, what I want to do is just use the 10 frames again, and I'll show you how that works. So in this case here, I'll set up a 10s frame. You'll see how that putting 2 of them together allows me to talk about this bridging 10 strategy, and we'll talk about what sits behind it. So I'm just going to set this up now, and you'll see here, to start with, we're going to make it very obvious. We're going to add 9, and I'll do the second 10s frame, I'll do in a different color. So we're going to add 9 and 6, and we'll talk about how you bridge in order to get this. So I'll just put these across here. So you can start to see, I can see there's a 5 and there's one more than 6. So here's my original question. We're doing 9 and 6 that are sitting there. Okay, when I'm doing 9 and 6, when I bridge the 10, you'll spot in a moment that there's a gap between what we need to do. So to bridge 10, I'm going to have to do what we have here. So watch as I do this. I'll just show you back on the 10s frame and you'll see what we mean. Okay, so you'll see here we've got 9 and 6, which is really 10 and 5. So you start to see how this strategy called bridge 10 works very nicely, particularly for numbers like 9 and something else, or 8 and something else. However, there's 3 things that matter when we're doing this bridge 10. I'll need to know facts to 10. For example, I just did 9 and 1's 10, so I need to know that fluently. I need to be able to split, or sometimes the words partition the 6 into 5 and 1. And then I need to understand it's okay for me to add the 9 and 1 to get the 10, and then 5 more to get the 15. So essentially, there's your 5 strategies that will do 100 basic addition facts. And remember, if you go back to that part, whole idea, so I'll just take you back to there for a moment. If you take the part, whole idea, there was a diagram that I put in. With that diagram, the part, whole, once I've learned my addition facts, all I do is start to cover some of these. And I work out what's 5 and 4? Well, that's 9. That's the standard sort of thing here. I can rearrange those parts that are sitting there. But let's look at another example. I can look at missing parts. The missing part might be there, and the missing part might be there. So essentially what we're doing here is trying to link the multiplication, sorry, the addition with the subtraction idea. Now, we've just got a couple of minutes, so I just want to share a couple of other short games that we might be able to use here. One is simply a game where, and I'll just put some cubes on the table there, and you can have a look. Now what we've got is a stick of 10 cubes. I've linked together 10, they're all the same color. We can either do this behind your back, or we can just snap it, but I just sort of snap the cubes, and now what I've got? Well, in this case, we started with 10. You can see I've got 7 and 3. Another way is I put them together, right? So there's the same cubes. I snap them in a different way, and I've got 4 and 6. Now, if I turn it around, I've got 6 and 4, but I've still got things that add to 10. So, you know, basically, you just put a set of 10 cubes or 10 Lego bricks or any blocks you've got, you stick them behind your back, you snap it and bring it around the front. You could do the same by putting them inside a bag. I call it a mystery bag, but it's a calico hot marble bag. You put them inside, you snap them, you bring them out, and you look at that sort of thing. So that's another example. Let's look at one other one. Let's say we had some cards. You can use any pack of cards for this, but basically you'll just want to have the ace to 9. This set of cards will have a 10 in it, which is pretty neat. But essentially we're taking the same idea that we've talked about before, a version of what I would call snap. So in snap, basically cards turn over. We might have 2 players and they're going to turn cards over. So this player's turned over 7, but we're not playing the traditional snap. We're playing snap to 10. So while I've turned over 7, what I'm hoping for is someone's going to turn over 3. No, we haven't got a 10. Now I've turned over a 5, so the next player turns, all close, nearly got to 10. What number am I looking for? Well, I've just turned over a 6. I hope this player turns, well, that would be a snap in the normal game, but not in this one. And I'm looking for pairs that are going to add to 10. And you keep playing until you get to that point. And so it's anticipate, oh, zeros come up here. So what number would I like to come up next? 10. So essentially we take a standard game, like the standard snap game that most people are pretty happy about, turning the cards over, and we just adjust it to a thing called snap to 10. So there's a bunch of little games that you can link to all of this. Now, I've got a much larger explanation of that with these things called milestones, and I'll just show you what a milestones looks like. These just sit up on my website. You're welcome to download them. But essentially, this is the basic facts, addition and subtraction milestones. And they sort of summarize everything that we've talked about today. What are the prerequisites? What are the things we need to have in place to do that? And on my website, I've linked all the little free games and things like 10 frames and the bead strings and the materials to each one of those so that you can see how it fits at a particular point. So look, I hope that's been a fairly whirlwind tour of all the sort of the basic facts, the single digit addition numbers. But if we can get that right, then it's going to make the rest of your schooling much, much better. So I guess people are going to ask me when you need to know these sort of things. Typically in Australia, by the end of year 2, you'd want to sort of experience and know them. And in year 3, we get faster at them. And that's when you play a lot of these sort of games to get faster at them. So thanks, Heather, for hosting us. I can see it's pretty cold over there. And you got up early in the morning to do that. So we appreciate that, and I hope everyone's found it useful.
Paul, thank you so much for today. Really appreciate it. We just want to thank your team and also for the 5 simple strategies. They're not actually that simple, but the counting larger ones, facts to 10, the doubles, near doubles, and the bridging 10. Just to let you know, my son, my husband, and I all play Ken at the moment from a previous webinar. So we've enjoyed doing that. Just say thank you again for your team. Just to let everyone know again, Paul has a lot of resources available, videos available. He's also done curriculum-based for year levels. Information on his website and on his Facebook page is updated all the time. There's also the webinar will be on your YouTube channel by the end of the week. Is that correct, Paul?
I certainly hope so, yes. That's our aim.
I'll ask your team later. But thank you very much. And look, happy homeschooling. And for the teachers that are doing an amazing job homeschooling parents, you know, hands up to you. I think you're amazing. Thank you very much. I've got 2 at home. So let's happy homeschooling. We hope to see you again.